This is Jane. After a long day debugging code, she opens her browser, types netflix.com, and presses enter. Within seconds, the Netflix homepage appears, ready to stream her favorite shows. But here's the question: how does the browser know where to go? How does it find the right server, the right page, the right content? The answer starts with that little line Jane typed at the top of the browser, netflix.com. That's called a URL, and it's the first step in how the web works. A URL, short for Uniform Resource Locator, is like a digital address. Just like your home address tells the mailman where to deliver a letter, a URL tells your browser where and how to find a specific file or page on the internet. Here's an example of URL with extra parts included to help us learn. Let's break it down. First is the scheme, here HTTPS. The scheme tells the browser how to talk to the server. Usually it is HTTP, which is the standard, but it is not secure. HTTPS, which is secure and encrypted, or even FTP for file transfers. Like choosing a language to speak, English, Spanish, or French, you and the server need to agree on the same language. This language is also called the protocol. The next part is the user info. Some servers, like shopping websites, streaming platforms like Netflix, or secure apps, require users to log in before accessing certain content. Technically, it's possible to include your username and password directly in the URL as shown here. But this method is almost never used today because it's a huge security risk. Sensitive information like usernames and passwords should never appear in the URL. Why? Well, because URLs can get saved in your browser history, be logged on web servers, or even be shared accidentally. That's why websites today handle login details securely inside something called the request body instead. More on that later. Next comes the host. This is the main destination. It can be a domain name like netflix.com or a raw IP address. The next element in the URL is the port. Think of the port as the door number your browser knocks on when it arrives at the server's address. So the host, like netflix.com, tells the browser where the server is on the internet. And the port tells it which entrance to use. Common ports are 80 for HTTP, or 443 for HTTPS. Netflix, being secure, uses port 443. After entering through the correct door, that is, the port, the browser needs to know what specific content it should ask for on the server. That's where the path comes in. The path works like a folder structure inside the website. It tells the server exactly which file, page, or section the browser is requesting. Here, for example, browse is the path to the browsing page that shows available movies and shows. The next part is the query string. This is an extra information sent to the server. It's like a request saying, show me the page for item ID 101, which could be a specific movie or category. And finally, the fragment. This part doesn't go to the server. It's handled by your browser. It tells the browser to jump to a specific section of the page, like the Trending Now row, once the page loads. So that's your URL, an instruction manual for your browser on where to go and how to get there. It says to the browser, go to Netflix securely, as user 123, through port 443, open the browse page, load item 101, and scroll to section 1. But once the browser has this instruction, how does it actually ask for the page? It does that by sending a request, like a digital letter, to the server of the website it's trying to reach. And that letter is called an HTTP request. In the next video, we'll open up that letter and look at what's inside, line by line. See you there! If you found this video helpful or eye-opening, give it a like and subscribe for more deep dives into real-world cybersecurity flaws explained step by step. Thanks for watching and see you in the next episode. Until then, stay curious and stay secure. Bye-bye!